Okay, hello everyone. Now let's solve a self-select set for carboxylic acid derivatives. Okay, so a standard outline. Okay, for the first point you should know from the organic lectures is to be able to recognize the functional group and be able to draw the structural formula and name this class of compounds. Okay, so now in this case carboxylic acid and ester. So what's the functional group of carboxylic acid? It's CO with a carbonyl group, next to it OH hydroxy group, okay? And for the ester, we have again carbonyl group, okay, and oxygen, but instead of hydrogen, we have alkyl group, okay? So in carboxylic acid, yeah, so this R can be either hydrogen or alkyl group, okay? In ester, we have two R's here. So this R can be either hydrogen or an alkyl group, but the right R, which is connected directly to oxygen, must be an alkyl group for it to be ester. Okay. Otherwise, if it is hydrogen, it will just be a carboxylic acid. Okay. Okay. So the first thing to be able to draw the functional group. Yeah, we already have done it. So if you subtract this number of atoms from the general molecular formula here, you'll be left with 3 carbons and 7 hydrogen for the carboxylic acid, okay? And if for the ester, you'll be left with 3 carbons and 8 hydrogen. So you just play around putting this number of carbons, okay, with any structure for this side. So let's first draw the functional group, okay? So let's start with the carboxylic acid. So this is the simplest one is just draw the linear alkyl group. Okay, putting the 3 carbons here and the hydrogen, so 2 hydrogen, okay, and 2 here and 3 here. And another possibility, so we have one possible structure. Another possibility is again draw the functional group, okay, carbonyl group here, and make it more branched if it's possible. Yeah, so. But I put the two carbons as a linear, and let's make one methyl group on the side, okay, so as a substituent to the second carbon, so 1 hydrogen and 3 hydrogens here. I think there's it's only 2 possible structure for the carboxylic acid which contains this number of carbon, okay. And for the ester, so I said, yeah, this part must be an alkyl group, so let's start putting all the 3 carbons, okay, on the right side. So again, just make all of them, just make it linear. So 2 hydrogen here, 2 here, and 3 hydrogens here, okay. And this part can either be hydrogen or alkyl group. In our case, okay, in this first example, it will be hydrogen because we used all carbons on the right side. And just continue, okay, moving one carbon, okay, to the left side. So again, first of all, draw the functional group CO with oxygen, and let's leave 2 carbons here on the right side, CH2, CH3, okay, and let's move 1 carbon on the left side, so it will be CH3, okay, one possible structure. And another, so I will continue drawing here. So again, let's move 1 more carbon and leave only 1 methyl group here, CH2, CH3, okay. So we cannot move the next carbon as I said here because here we have to have at least 1 carbon methyl group, okay. And the last possibility is to make this side, okay, look differently, yeah, in terms of structure. So here, there's oxygen connected to the propyl group via the first carbon, but it could also be connected to this propyl group via second carbon. Yeah, so I'll draw it here. Oh, here, let's make all the esters on the right side. So I'm connecting to the propyl group through the second carbon. So 1 hydrogen here, and here I have 1 hydrogen. Okay, so we have at least drawn, so 1, 2, 3, 4, 5, 6, yeah, 6 molecules. Now let's try to name them according to IUPAC name. So for the carboxylic acid, here again you have to start numbering from the functional group. Okay, for aldehydes and for the carboxylic acid, it's all the same. So the first carbon, second, third, and the fourth. So it's linear, no side groups. Okay, so it's just butanoic acid. And the second one, here we have the longest chain. So first find the longest chain. So this is the longest chain, or it could go this way. It doesn't matter. It will be same. So 1, 2, 3. Yeah. So we have a methyl group on the second carbon. So 2 methyl. Propanoic acid. Okay. 3 carbons. Propanoic acid. Okay. So if we finish with the carboxylic acid, now what about naming esters? So in naming esters, this part which is connected directly to the oxygen, okay, this R, will always be named first, okay, and the second will come as this, the left side part, which comes from the carboxylic acid, okay, including this carbon in the carbonyl group. Wait a second. So let's try to name this one. So we have 2 carbons here, so ethyl, and 2 carbons on the left side, okay, including this carbon, ethanoate, ethyl ethanoate. So 8 means an ester, okay, ethanoate. So this one we have propyl, just linear, which is connected by the first carbon. It will be just propyl. So propyl, only 1 carbon on the left side, okay, so methanoate, propyl methanoate. And this one here, we have only 1 carbon on the left side. So starting from that spot, methyl. So 1, 2, 3, propanoate. And this one here, again, so this part will come first, but here we have to show that the oxygen is connected to the propyl group via the second carbon, okay? So it would be isopropyl. Isopropyl methanoate. Okay, so isopropyl is a trivial name. If you use IUPAC, it would be 2-propyl methanoate, indicating propyl connected by the second carbon. So 2-propyl methanoate. Okay. Okay, now let's move to the next question. So next one, we have to know the tests which can be used to distinguish or to identify that functional group. Okay, so here we have a carboxylic acid and an aldehyde. So which test can be used? I mean, what kind of reaction aldehydes undergo? Okay, and which is not applicable to the carboxylic acid. So it's obvious, it's oxidizing agent, oxidation reaction. Okay, so aldehydes, remember aldehydes and primary and secondary alcohols, they do undergo oxidation reaction, whereas carboxylic acids, they do not undergo, and ketones as well, the oxidation reaction. So oxidation reaction, okay, so I write oxidation, and you have to know this, at least 3 common oxidizing agents, okay, oxidation reaction. So example would be a dichromate ion, potassium dichromate, for example, in acidic condition. Okay, so if you use dichromate in acidic condition, aldehyde will be converted to carboxylic acid, changing the color of the solution from red-orange to green. Okay, whereas with carboxylic acid, the red-orange color will stay as it is; it will not change. The second one, we have again carboxylic acid and an ester. Yeah. So remember, carboxylic acids and alcohols, they react with sodium metal or to give or sodium hydrogen carbonate to give a hydrogen gas. Okay, so if you react carboxylic acid with a sodium metal, let's say, okay, so you'll produce a carboxylate ion, a salt. So hydrogen replaced by sodium, and hydrogen will be released as a gas. So you will see bubbles. Whereas ester, you don't have that hydrogen here, okay? So it will not undergo a reaction with the sodium. So sodium can be used. or sodium hydrogen carbonate. Okay, in the reaction, in the case with the sodium hydrogen carbonate, you will see the gas again, the bubbles, but in that case it will be a carbon dioxide gas. The last one is carboxylic acid and an alcohol. Yeah, so in that case, do you see you cannot use a sodium metal because alcohol will also give positive result with the sodium. However, it again is a common test. Oxidation can be used to differentiate these two functional groups. So alcohols, primary and secondary, remember, they do give positive result with the oxidation reaction. So it's again oxidation. Whereas carboxylic acid will not undergo oxidation reaction, and tertiary the same. Okay, oxidation, and the example would be, let's say, Helen solution. Okay, in alkali condition. So in that case, the color of the kappa 2 plus, which is blue, will be changed from blue to red orange. Okay, and that would be specific for the alcohol. So alcohol will undergo, and then carboxylate will not undergo. So here esters will not give positive result with this reagent, and this one will do. And here no, yes. Okay. So do you see what I mean? You should know the color changes.